Good morning. So many thanks for the Linux Foundation for organizing this wonderful workshop. So today I'm going to talk to you about one of the key innovations in the AI networking, the use of SRv6 microSID in SONiC for AI backend. My name is Ahmed Abdelsalam. I work as a tech lead in Cisco systems. And this is a joint presentation with my colleague Changrong from Microsoft. Unfortunately, he could not be here on site this time, but maybe next time we will present together. Okay. So if you have been following what is happening a bit in the industry over the last few months, very likely you have seen that Microsoft has presented publicly several times about the use of SRv6 in the AI backend. So at the OCB summit in Dublin in April, Gohan from Microsoft actually explained very precisely and very briefly the problem statement of AI backend and why SRv6 makes sense there. And here is exactly what he said during his presentation. First, in the AI backend, the traffic or the training traffic nature is very bursty. So you have a lot of elephant flows. Those elephant flows have very little entropy. And that leads to the problem that the traditional hash-based ECMP does not work. Why? Because, and it's actually particularly bad because those training jobs are highly synchronized. So if you get one or more flow colliding on the same link and this link get congested, this basically delays the whole job completion time. And so what do we do then in the AI backend? The answer he gave to the question is that the source routing here is the right solution to solve this problem. And what he said exactly is basically that SRv6 is a very perfect technology to do such source routing in the AI backend, and that's what we will go through it during the presentation. In another presentation also from Microsoft, Rita at the MPLS and SRv6 World Congress in March this year in Paris, she explained the reason why they like the SRv6 as a technology to do the source routing in the AI backend. And here is exactly what she said during the presentation. The first reason is that as a source routing technology, it gives the source a precise control over the traffic flows to, to achieve optimal traffic performance. A second reason is that as a source routing technology, it allows you also to enumerate all of the different passes that you have in the fabric and then use them smartly after to, to optimize the traffic placement. One of the key points also that she mentioned is that is the tight coupling between the AI workload flows and actually the scheduler. And last thing, which is, again, one key point, and you will see it when we show a bit of, let's say, of visualization of how you do SRv6 in the AI backend, is actually that the failure detection and respondence to this failure is completely at the source. So the source can reroute the traffic, recalculate the path, completely independent from the routing protocol or the protocol that you use in the fabric, and we will see a bit into more detail. Together also with other partners from the industry, Oracle Cloud, IBM, NVIDIA, and Arcus, we published an IETF draft that explained the use of SRv6 in the AI backend. In this draft, we mentioned the benefit, or we explained the benefit of using SRv6 in the AI backend, and you have the link here for the draft, but one key point that I would like to highlight is that it's a standard open solution. There is nothing proprietary here. Every piece of the SRv6 solution is a standard. And because of this technology being a standard, you have a much easier way to operate the network and troubleshoot it compared to any kind of, let's say, black box solution that you may see in the industry. Before going into the use of SRv6 in the AI backend, I would like to give you a bit of, let's say, small update on what is SRv6 and what actually is the innovation behind this technology. We all use the IP protocol, so it's the heart of our, let's say, networking industry. But unfortunately, this protocol for 40 years has been always limited to doing best effort let's say, services. It's just an address that allows you to localize your endpoints. And in order to deliver any service on top of this protocol, we had to define a several set of shim layers. So, and we do it per domain. So we did MPLS for the core network, we did VXLAN for the data center, GTP in the mobile, et cetera, et cetera. But unfortunately, those let's say, shim layer did not completely solve the problem. For example, in MPLS, you lose one of the key scale feature of the IP protocol, which is summarization. In order to scale, you need to summarize. In MPLS, there is no summarization. In VXLAN, for example, you don't have any kind of notion of traffic engineering to steer traffic through multiple hops. So again, it doesn't work for traffic steering. But because also these protocols has been defined on per domain basis, then in order to connect those domains, you need a kind of translation gateways. And we all know a gateway is typically expensive, complex to operate, and leads to inefficiencies because it has to talk to different protocols. What actually happened with the SRv6 microset technology, that the IPv6 protocol became completely programmable. So in the destination address of the IPv6, which is 128-bit, you can encode up to 6 instructions. So this instruction, you can bound them to traffic engineering, overlay, underlay, whatever behavior you want. So just in the destination address, you can have all of the service, encoding of all of the services that you need. How many of them you can have in just a single destination address? Up to 6 micro instructions. And most of the deployments actually require less than 6 TE waypoints in reality. But if you have like ultra scale traffic engineering use case, where you need more than six hops in instruction, you have the segment routing extension header for scaling, but this is rarely actually used. Again, as we mentioned before, this is a fully standard solution. So every, let's say, piece of the SRv6 technology is standardized from architecture, control plane, and all of the different components. We have been leading that standardization effort, and we are co-author of all of these RFCs. What is very also important for the community is the ecosystem. So we have a very rich ecosystem, both from, let's say, network vendor viewpoint, but very important from merchant silicon viewpoint. So you have all of the merchant silicon supporting this technology, and actually across all of the different family of the ASIC. For example, at Cisco, we support, in the Cisco Silicon one, we support SRv6 microSID, both in the platform for access, Metro Core, and very importantly, in the data center family of ASIC. We have also a very rich open source ecosystem. In FRR and SONiC, we have extremely rich and open source support, and also we will go a bit into the details of this during the presentation. Now let's see how we can use this SRv6 technology in the AI backend. Here I will use some of the slides that was already presented by some colleagues from Microsoft to show you an illustration of how you build an SRv6-based AI backend. So what you see here is a typical fat tree closed topology. What I show here is just two tiers. So tier 0, tier 1, the typical spine leaf, but it works exactly the same also if you have tier 2 or super spine. In this topology, every node gets assigned an identifier. In the SRv6 terminology, this is called an SRv6 locator. And how you assign this locator, it's very straightforward. You take an IPv6 prefix, which is /32 prefix. You assign each one of the devices and a locator out of this 32-bit prefix as a /48. You can see it in blue here, what is the identifier of each device. Once you do that, you have identification of all of the nodes. You have the topology, so you can compute for each GPU to GPU communication a specific path. And again, to remind you about the characteristics of the AI backend traffic, it's an elephant flow, long-lasting, and actually deterministic. You know who is going to talk to who for some time. So you can compute a path for each, let's say, NIC to NIC or slash GPU to GPU communication. And what you compute is just a destination address that will be used in the encapsulation of the SRv6. SRv6 is nothing than IP and IP in encapsulation. So you will encapsulate this traffic with an outer IPv6 header that has the destination address that you compute. And actually, you can read the destination address even by looking at it. So what does it mean, this destination address that you see? Go to node 1 in tier 0, then from there go to node 1 in tier 1, then go again to tier 0 at node 256, where you go to NIC B. That's how you do it. But another key point for the AI backend is the fast reaction to congestion or network failure. Once a failure happens in the network, with all of the different, let's say, congestion notification techniques, now you get a notification back to the source. So what the source is going to do is going to reroute this traffic through a different path to avoid the congestion or the network failure. And this can happen extremely fast because you can have those actually backup passes pre-computed, and it's just a matter of it changing the destination address of the encapsulation will take the packet from this congested path to the new path that either not congested or avoiding the failure that you have at one node. To give you a bit of, let's say, illustration, again, with some of the slides that was presented already by the colleagues from Microsoft, how it's different from using the typical hash-based ECMP load balancing compared to using SRv6 as a source routing technology to place the traffic in the AI backend. Here, what you have is a set of ECMP passes, and you have multiple sources that's going to send the traffic. Again, these rocky V2 flows have little entropy, so you're likely going to have some flows colliding on one link, causing congestion. If you are using SRv6 and as a source routing, what you're going to basically to do is that you can have actually a full control of the enumeration of all of the passes in the network. You can assign them to the flows and avoiding having any kind of congestion between the different flows that you have in the network. SONiC, so we are in the SONiC workshop, and basically SONiC is a key platform used typically in those AI backend network. So in SRv6, we have extremely mature support in the SONiC. Just to give you a hint, since 2021, when we started the SRv6 support in SONiC, we have more than 350 PR and more than 1,600 commit merged through SAI, SONiC, and FRR. This adds support for many features, including the static steering of the traffic for the AI backend that you have just seen, also for other operator use cases like overlay or layer 3 VPN, underlay traffic steering, and other use cases. This is a mature, let's say, support which is deployed already in production for some years now in Alibaba across China. And also, if you have seen the slides or the previous presentation from the colleagues from Microsoft, that this is also used, how to say, in they use SRv6 in SONiC for the AI backend. It has also a very rich ecosystem with key contribution from Cisco, Microsoft, and Alibaba, but you have the whole industry, let's say, contributing there. Focusing a bit on the SRv6 support in SONiC for the AI backend, again, with some numbers, just in the time frame between October 2024 and May 2025, that's basically the time frame for the SONiC 2505 release, we have a total of 122 pull requests that has been merged across SAI, SONiC, and FRR mainline. Cisco and Microsoft has been leading this with a great contribution also from the colleagues at Alibaba. So in this SONiC 2025 release, it has been released a few months back. The SONiC community already authored a blog on this, and you can see that one of the key features that has been added into this release was the SRv6 support for the AI backend. To stay up to date on what is happening on SRv6 in the AI backend in SONiC or generally, at the next OCP Global Summit in San Jose, basically there will be at the main conference, there will be two interesting talks. The first one is from the colleagues from Microsoft on the use of SRv6 in the AI backend. The second one will be a joint talk between Cisco and Alibaba on the SRv6 design that they did. Typically, every year we host what we call the SRv6 Roadshow. It's around end of the summer, beginning of October, where we invite all of the SRv6 operators from around the world to come and share their experience about the SRv6 technology. The last two editions were very successful. So in 2023 in Rome and 24 in Nice, we have a very successful event with more than 100 attendees each and many testimonial customers. So if you are interested to join, please send a message and we will be happy to welcome you at the event. We also wrote a book on SRv6. It's already available since the end of 2024. So if you are interested to read it. And the last thing, the best place in order to get the latest information about SRv6, always to go to the segment-routing.net, where we publish all of the latest updates on the technology, the latest deployment, etc. Thank you.